So our first kind of major project at CSIRO working together was on automating draglines. So draglines are these very large machines, Draglines are these very large machines, something up like 3,000 ton machines. They're a little bit like cranes. Instead of lifting things just up and down, they also pull towards the machine itself, and they sort of uncover, they lift dirt and uncover coal in coal mines typically. So there was a need to partially automate those to improve efficiency. So we started working on that project. Peter and Graham had been working on that the year before I arrived. And then when I arrived, we started doing some kind of serious field work and actually trying this stuff for real. And we started on a scale model, which was based out in Brisbane, sort of near Ipswich. It was like a 10th scale model dragline. We implemented all this vision stuff that I knew about from my PhD days. And we discovered it was actually quite a hard problem. We put a camera on the top of this dragline looking down at this bucket, which was full of dirt. And of course, the background is dirt. And anyway, it turns out that looking for a bucket of dirt in a background of dirt is hard. So, after a while, we kind of gave up on using the camera system, and we bought some lasers. And we'd figured out that because we've got these ropes hanging down, lifting this bucket, if we put the laser kind of looking out horizontally, we would see these two ropes swinging past. And that was kind of the secret of the dragline system, to actually figure out where this bucket was. So the heart of the problem was how you control this very heavy bucket, which may be 100 tons, and it's kind of swinging around because the dragline kind of picks up from one spot and rotates on the spot and dumps the dirt somewhere else. So it's a pendulum, basically. And Peter was the control expert in how you control a big pendulum like that. And it was my job to actually figure out how to measure where the ropes were on that pendulum. And Graham was managing the sort of the whole project behind the scenes.
Okay. And end results?
Yeah, that project lasted many, many years and had different phases. So we demonstrated on the model dragline, and we then moved to a full-scale dragline at a place called Tarong Coal, which is near the town of Kingaroy. It's about a 3-hour drive out of Brisbane. And we spent probably a couple of years going up there, once a month, installing equipment, installing lasers and control systems, and generally kind of proving the concept, and we proved that worked. We then had a follow-on project where we went to another mine up near Billawheeler. So that was like a 6 or 7 hour drive. And again, we would go every Sunday, every 3 or 4 weeks. That was their down day where we could install stuff. It was a Monday, so that meant all these weekends we would be doing the big drive up there, and we would again go and install all the stuff and do these amazing experiments, which at the time, was very much the largest robot in the world. And in fact, NASA had a web page back then, which was had Robot of the Week, and we got it on there as the largest robot ever made. It was exciting days when I remember the very first time we turned on the computer interface, and we had just a little mouse, and we had to move this mouse, and we could see the bucket go up and down, so literally turning this, up until that time it was a manual machine, turning it into a computer controllable machine.
What was the hope, commercial application? That this would be fully autonomous thing?
No, the hope was really to give the operator a kind of a smarter machine. So the theory with performance of operating these complicated machines is the operators are extremely good some of the time. Maybe when they start their shift because they're rested and they're great and all that. But then of course as time goes on, they just get more tired. Right? It's as simple as that. So the idea was that maybe a sort of a semi-automated machine could, on average, be better than an operator. It would never be as good as an operator, when they're on top of their game and really focused, but it might be better than the operator when they're super tired and towards the end of the day. So as long as the robot system would then be consistent. So as long as it was consistently better than the human operator, then we would get some performance gains. And the other motivation was human operators just naturally can be a bit rougher on machines than you might want them to be. So you can, program the automatic system to be super smooth. And that then has massive maintenance benefits because draglines need, they're a very big steel structure, and if you don't treat them right, you'll need to maintain them more often. So it was all about performance of the actual speed on average and reducing maintenance.